No. Yeah, that's over. All right, so I handed out your notes while y'all were doing ACT Aspire, but we still need to go over 26 through 30 of your ACT packets because we haven't gone over them yet. So, does anybody need 26? I know y'all are still getting stuff out. We are recording, by the way, because I wasn't able to record during second period, okay? So just keep that in mind today. 26? Yes? Okay. What? What? I didn't hear you.
I said, what do you think will say something mean or something?
No, I'm just reminding you, just keeping you honest is all. All right, so 26, let's see. The temperature T in degrees Fahrenheit in a certain town on a certain spring day satisfies the inequality. Which of the following statements in this degree Fahrenheit is not in this range? So let's see, plug it in. The answer you should have gotten was F. So if you plug that in, what is negative 10 minus 24? Negative 24, right? Negative, I can't write today. 34. And 34, the absolute value of that will be positive 34. And that is not less than 30. So your answer should have been F. You could have done that just real quick by plugging them in your calculator, okay? All right, what about 27? Does anybody need 27? Yeah? Okay. If 5 times the number n, so 5 times the number n would be 5n, right? Is subtracted from 15, the result is negative. Which of the following gives the possible values of n? So let's see, if that is subtracted from 15, like that. So what's it mean if the result is negative? So does that mean it needs to be less than, or does it need to be greater than? What do you think? Less than. And what number does it need to be less than for it to be negative? 0. Very good. So if we move that 15 over, remember that this 15 is positive, right? So we would move it by subtracting. Y'all okay so far? And what happens when we divide by that negative 5? It switches. Very good. When you divide or multiply by a negative, and that gives you 3. So what is that? Is that D? Yep. Yep. Y'all okay? Why did I do 0? Because right here it says the result is negative. So if it's negative, that means it needs to be less than, right? What's the only number that sits between negative numbers and positive numbers? And that's 0. Does that make sense? Okay. All right, do y'all need 28? Okay, 28 you just need to factor. So look at this first piece right here. This x squared plus 8x plus 7. How does that factor? Say that again. I can't hear you. X plus 7 and x, I'm assuming and hoping you said 1. And then you have, let's see, x minus 3, right? What about the bottom? Is that 21? Is that what that says? What's the factors of 21 that add or subtract to be 4? X minus 3, x plus how much? 7. Very good. And what do you notice? X plus 1s cancel. Why do they cancel? Because they're the same on top and bottom, right? Anything divided by itself is 1. So let's see, the 7s cancel out, the x minus 3s cancel out, and don't tell me my answer is 0. It's 1. Anything divided by itself is 1. So your answer is F. You just had to factor, okay? If you know how to factor, that should have taken you less than a minute, right? The faster you can do some of these, that gives you more time for other ones. All right, what about 29? Well, yeah, but do I need to go over 29? No? Nobody needs 29?
You do 30.
I can do 30? Yes, ma'am. Let's see what 30 says. Oh, 30's the circle one? Alright, let's see what it says. Forgot the distance formula? Stop. Alright, let's read what it says. It says, the figure below shows 2 tangent circles such that the 10 centimeter diameter of the smaller circle is equal to the radius. Okay, so what's that mean right here? It says that two circles, 10 centimeter diameter of the smaller one. So you see how it stretches all the way across the smaller one, right? It's just that the air sucks it close. So it says that that's equal to the radius of the larger one. So what does that mean the larger one's diameter is? 20. So the small one's diameter, or should I say diameter of the small one, is 10. Diameter of the larger one is 20. Does that make sense to everybody? Alright, what is the area of the shaded region? So you have to remember the area of a circle is how much? Pi squared. There you go. Pi squared. Remember the area of a circle from geometry? Y'all okay? Alright, so what do we have? Let's do the smaller one. So that would be pi times 10 squared. No, that would be the large one. Y'all okay so far? The radius of the large one? What is 10 squared? 100. Does it give us that? No. What is the area in centimeters of the shaded region? Okay, so if we found the area of the big one, now we need to find the area of the small one, right? And do what to the two answers? Subtract one. So let's see. Let's do area of the small. What's the radius of the small one? 5, half of 10. What's 5 squared? 25 pi. And subtract them and you get how much? 75 pi. There you go. Okay. Y'all okay with that one? Anybody lost? Okay, so what's your homework tonight? Check your answers for which one? 31 through 34, and we'll go over them tomorrow. Now, I handed you some notes. You do need a graphing calculator. They are very, very simple notes today. Very simple notes. And we will have a quiz on Thursday. We will have a quiz on Thursday. We're about a day off from your calendar because we had to do the ACT Aspire yesterday. This should be a very, very, very easy unit. It should be a very easy. Now it is very different. The only thing that you have ever seen out of this unit should be section 7.1, which is the graphs at the bottom, okay? And you probably briefly went over them very quickly. Probably didn't do much. We're not going to do much with them, but we are going to start here. Y'all ready? Alrighty, here we go. Let's look at the bottom down here. Now, there's a couple of things you need to know about these graphs. First thing, you ready? And this is big. How do I know that these are exponential functions? What tells me in these functions to start with, in the equations to start with, that they're going to be exponential? Don't tell me exponent. What is the exponent? X is in, or a variable is in the exponent, right? That is very important. So on your quiz on Thursday, if you get that question, how do I know that this is exponential? Don't tell me because of the exponent. And it's recording right now, so I can come back and play it, because if you say I didn't tell you, it's recording. It is not the exponent. The variable is the exponent. Does that make sense to everybody? Got it good? So don't say I didn't tell you. All right, here we go. Hint, just saying. Graph each exponential function. So, do you have your handy-dandy calculator? Where do we go to graph something? Y equals. And what are we going to plug in? How do I put in 2 to the x? How in the world do I put that in? The little caret button right below clear, right? And then x. Y'all okay? And then what do we do? Hit the graph. That's it. Now there are 2 types of exponential functions. Does anybody remember the 2 types? Read the top of your paper somewhere. Growth and what? Decay. There are 2 types. You need to know them. You ready? Growth and decay. You need to know the two types of functions. So if on your quiz Thursday I were to ask you, what are the two types of exponential functions? What would you say? Growth and decay. Get it? Got it good? Okay. What do you think growth means? That it's positive, it's going up. What do you think decay means? It's the opposite. It's negative, it's going down. So what is number one? Number one is a growth. How do you know that? Because you read these like you read a book. From left to right, what is that graph doing? Is going up. This is a growth. Then there is a way that you're handed any calculator. Y'all okay? Good? Okay. You need a minute, Casey? Okay. Blah, 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 where were we at? Okay, there is a way for a handed any calculator to give you points. Where is that at? How do I get to table? Second table or second graph. Now, when you do that, you might have a whole bunch of craziness pop up, okay? So, this is not what you have to do. This is just works. This works well for me. It works well for me to find the whole numbers first, okay? You don't have to do that, but it's easiest for me to do that. So I'm going to do that way. So I'm going to go 0, 1, plot that point. Then I have 1, 2, 2, 4, what is it, 3, 8, is that right? And then 4, 16, I don't have enough room. So the reason that that's easier for me is because, do you see how that curve is already starting to form right there?
Yeah.
Alright, so let's go on the other side. Let's do some of these on this side. Let's see, -1. What's -1 have? 0.5, okay. And -2 has 0.25, which is like barely above the line on this little bitty tiny graph. And -3 is like right there. Alright, so look on your calculator. All of those points are getting closer and closer and closer to what number? 0, right? Why are they getting closer and closer to 0? Because I'm not adding or subtracting anything back here, right? So let's talk about your money. You ready? Y'all love money. I love money. We all love money, right? So, when you go to the bank, when you get older, you might do something called open up a CD. Do y'all know what, if y'all heard the word CD? Not the CD that holds music, but like a CD, a money CD. You heard that before? Huh? The bank holds money, yes. You have one, Sam?
No, I've heard the one about.
You've heard the one about the music. Oh, wow, that really makes me feel old that you just said that. Okay, we're going to talk about the one for the bank. Okay, so there are different types of CDs. You ready? There's a 6-month CD. There's a 9-month. There's a 12-month, which is a year. There's a 24-month, which is 2 years, right? There's all these different CDs. So what a CD is, you ready? You have some money, and you go to the bank, and you say, hey, bank, I want to open a CD. And they're like, cool. What kind of a CD? How long would you like to open it? And let's just say you want to open it for a year, right? So you go to the bank, you give them your money, and you cannot touch that money for a year. So you know how you have a savings account and like you can go put 20 bucks in, right? And the next day you can go take out 20 bucks. With a CD, you can't do that. So why does the bank want your money in the first place? Because what does the bank do with your money? They give it away. I go buy a house, they give me that money to buy a house. You go buy a car, they give you that money to buy a car, right? So because you go and put your money in the bank gives you what in return for keeping your money there? They give you interest. So the cool thing about a CD is that, look what happens. You start at how much money? 0, which is why this line is getting closer and closer to 0, right? And if you're not touching it every single day, or actually I think it's about every month, what's happening to your money? It gets interest. So what is it doing faster and faster and faster every day? It's growing with interest. Does that make sense to everybody? So if you go into banking, you have to know about exponential functions. And we're going to talk about some cool exponential formulas that you could use If you want to be a real estate agent, you have to know how to... Has anybody's parents bought a house lately? No? Last year lately? Did you see the real estate agent where they take their calculator and they're doing all these numbers in their calculator, and then they'll tell your parents, like, this is how much you'll owe or whatnot? Kind of see that? The real estate agent has to know how to do some of these formulas right then and there. Y'all good? All right, here we go. What else does it say to do? What's the domain? Left to right. How far does it go to the left? And how far does it go to the right? So, what if we call that instead? Beautiful. Kitty got it good? You might have if you had your pencil in your hand and you weren't falling asleep on me?
Does it not ever hit 0?
No. Not in this case. In real life, yes, it will hit 0. Alright, so, what is my range? Oh, it's not all real numbers. How far does it go? A little bit above 0. If it's never actually going to touch 0, what do I use right here in front of 0? A parentheses. Means that it's open. Means it gets closer and closer and closer to 0, but it never actually touches. Now, ladies and gentlemen, in real life, it will actually get to 0, right? Eventually. All right. Where is it going up to? Infinity. Positive. And since it cannot ever get to infinity, it gets a parentheses. Does that make sense? Remember parentheses and brackets? It's been a minute. All right, let's look at number 2. No, because it's going to, in real life, yes, Sam, it will hit 0. But on this graph, it's going to get as close and close and close to 0 as possible, but never touch it.
Oh, never touch 0?
Not on this graph.
Never.
Ever. So what does that mean is running right along at 0? What's that A word? Asymptote. Very good. It's an asymptote, meaning it's like the center of the road, right? You're never actually supposed to cross over the center of the road unless you want to die or kill somebody else. Don't do it, okay? So let's go to number 2. Number 2, here we go. We're going to go to y equals. What do you have to do first? Parentheses, 1 divided by 4. Then you must close your parentheses, right? Hopefully you're using your calculator with us and you're doing this with us. And then you hit the caret button. Please don't make me call you out. And then you hit the X button. Got it good? And what do we do? Graph. Graph first. What is it? Decay. Why is that? Well, how do we read it? We read it from left to right. It's going down from left to right. Wait a minute, what in the world told me it would have been growth and decay in the first place? I thought decay would be a negative.
It starts because the slopes go down.
What? What, Casey? A fraction. So what tells you before you even graph it, what tells you it's going to be decay? A fraction. So what would a negative do? A negative would flip it, right? So it's going to be upside down here at the bottom. We're not going to get to those yet. All right, now we go to second table. It is easiest for me. You don't have to do it this way, but it makes my head not hurt so much if I start with my whole numbers. So 0, 1, negative 1, 4. You can see this one's growing a little bit faster, right? Somebody put in a little bit more money on this one. Yes, ma'am. Caitlin, did you have a question, baby? Or were you just putting your jacket on? I'm sorry. All right, let's see. Negative 2, too much, right? So let's go the other way. Let's see, 1 and 0.25. 2 and like just I can't even get my pen to write that small. This one's, if you're left-handed, this one's easier to draw. Decay's easier to draw. And again, once again, it's not going below what number? 0. What in the world is making it not go below 0? What could make it go below 0? Ooh, negative where? Not in the front. Negative flips it upside down. Not a negative exponent. Like number 3. Very good. A negative in the back. Remember, that's your y-intercept that moves it up and down. All right, here we go. What's my domain? All real numbers. Ooh, is it always going to be all real numbers for exponential? Yes, it will. Yes, it will. All right, what about my range? Range is starting from the bottom, right? Remember the crazy song? Y'all thought I was crazy? What's the bottom? Does it get a parentheses or bracket? Parentheses. And where does it go up to? Up. It goes up to positive infinity. You okay, Sam? Okay. I know. The struggle was real for me this morning, so don't worry. You good? Okay, number 3. You ready? Number three. Here we go. Who has a yellow calculator that I may borrow, please? You have one? Let me see that real quick. Okay, let me show you the difference between these two. You ready? Okay, watch what happens. So you type in 3. Good. Then you hit an arrow. Do you see the difference between the two calculators? Do you see how that mine pops it up already in the exponent? This one does an arrow. Do y'all see that? Okay, if yours is like mine, what was it, x plus 2? If yours is like mine, you can just hit x plus 2. Then you have to hit the right arrow button and then subtract 2. If yours is like Elise calculator, you have to use parentheses, x plus 2, close parentheses, then minus 2. Does that make sense between the two of them? If you have your own calculator, most of yours are already updated. If you're using one of mine, I think I only have like 2 that are updated just because it takes forever to update them. And I ain't got time for that. So, thank you, Elise. Alright, so what happens on this one? Growth or decay? How did you know that before you even graphed it? Because it's a whole number, not a fraction. There you go. What else do you notice about this one? It's below 0. What moved it below 0? The -2. There you go. So go to graph. Go to table. I'm going to start at -2, -1. Would help if I went to -1, not +1. Don't look at that. Oh, -1, +1. 0, 7. And that's what? No. Look at this right here. What does that do to the graph? That one is okay. That one's not going to go below what number? -2. There you go. All right, let's see. Let's go the other way. -3 and right above 2. -4 and a little bit closer, right? So it's going to flatline right there at 2. Like that. Y'all okay? Pretty easy, right? Thank goodness you have calculators and you don't have to plug in numbers the way we did in the old school ways. Here we go. My pen just, no, it's not supposed to hit 2. I just can't draw it. Now your calculator is, instead of going -1.99998 and -1.9999998 and -1.9999998, instead of writing all those numbers, it's rounding. But in real life, if you were to use a computer that has more room, you would see it has all the decimals. Or some calculators could have it -1 times 10 to whatever number in scientific notation. All right, what's your domain? All real numbers. And my range, be careful.
-2.
Parentheses or brackets?
Brackets.
Parentheses. It's going to get close and close and close, but it's never, these are always going to be parentheses. And then it goes up to positive infinity. Y'all okay? All right, flip it. That's all of 7-1. Woohoo, we just finished the whole section today. All of 7-1. Now let's go to the back and let's do 7-2. Oh, it's just as easy. You'll be all right. All right, here we go. Algebra 2. You have not seen this stuff before. This is Algebra 2, but it's pretty easy. You probably haven't. What? It is, I promise. The other stuff was easy. You just use your calculator. All right, you have to remember rules of exponents. Here we go. You have to make them have the same base. Right now, what are my 2 different bases? 4. All right, so ask yourself, can you make 4... Excuse me, let me say that again. Can you make a base of 4 to a certain exponent become 64? All right, 4 to what power? 4 to the 3rd. There you go. So I'm going to bring this down. And 64 is the same as 4 to the 3rd. If you don't believe me, use your calculator. Now and only now that they have the exact same base, what can I do to their exponents? You can set them equal. Very good. Then you can add and subtract. Add the 1, and you get 2n equals 4. Divide, and n is 2. No. So let's plug in that n right here. Ready? 2 times n is 2 times 2, which is And then minus 1 is 3. And what's 4 to the third? 64. Are y'all okay? Yes, because it said solve each equation. All right, here we go. Number 2. I have bases of 3 and 27. I need my bases to be the exact same. Not square root of 3. What'd you say, Elise? 3 to the third is 27. So I'm going to bring this one down. 3 to the 5x. Y'all good so far? Okay, 27 is 3 to the third. I'm not finished, okay? Just hold on a minute. I'm not finished. Are y'all okay on where I got 3 to the third? Okay, what else did that have? That had, there you go. So up there in that exponent, it's 3 times 2x minus 4. Now and only now that they have the same base, you can go ahead and say 5x equals 3 times 2x minus 4. If you're good and you can go ahead and distribute the 3, save yourself a step, because that's what we're going to do next. Y'all okay? All right, subtract the 6. You get negative 1x is equal to negative 12. And x is equal to positive 12. Y'all okay? If you wanted to plug it in, you would get some astronomical numbers, but they would come out to be the same. You want to try 3 real quick? Okay, y'all try 3, and then we're going to come back and do 4 and 5 together. Y'all try 3. Okay, so which one should you change? The 49 or the 7? 49 is 7 to the second. Very good. All right, and you should have gotten a decimal, or let's keep it a fraction. Let's not do decimals. So let's say distribute. You get 2x plus 10. Y'all okay so far? Okay, if we subtract the 2, 8 minus 2 is 6x. If we add the 6, 10 plus 6 is 16. Y'all okay? All right, so that'll be a fraction. And that reduces to 8 over 3. And if I wanted to do a mixed number, what would be my mixed number? 2 2/3. Very good. Very good. Y'all okay? Good. Not bad, right? Okay, these two are different. You ready for 4? Okay, I have to make 64 be a whole number, not a fraction. So how could I rewrite 1 over 64 to be a number with an exponent? How could I rewrite this? What makes me... To the negative 1. Very good. Very good. Remember, when that number is on the bottom, it means the same as a negative exponent. Is this bringing back some memories? Okay. Now it's just like number 1. 4 to what power is 64? To the 3. And that 3 is being multiplied by the original exponent, which is negative 1. Now and only now that they're the same base, you can say 2x minus 5 is equal to 3 times negative 1 is negative 3. Add the 5. 2x equals positive 2. Divide and x equals 1. Y'all okay? Plug it back in. What's 2 times 1? 2. What's 2 minus 5? Negative 3. And then we had to start with negative 3. Get it? Got it good? All right, all right, all right. Number 5. Number 5 is a little different. It's a little tricky. You ready? Can I do 9 to any power to give me 27? Can I do 27 to any power to give me 9? No. Do they share a common power somehow, though? A common base somehow? Base of how much? 3. 3 to what power is 9? 3 to the 2 is 9. 3 to what power is 27? To the 3. Are y'all okay with that? All right, now that they have the same base, you can set their exponents equal. Bless you. Distribute. Add the 2, you get 20x. Add the 30, you get 40. Divide and x is 2. Y'all okay? Got it good? Okay, here's the deal. You ready? The bottom of this is homework. The bottom of this is homework. Tomorrow, listen, listen, listen. Tomorrow, what do you think we're going to do tomorrow? Well, yeah, we will go over homework, but what else do you think? If we got a quiz on Thursday, checkpoint tomorrow. We're going to do one more lesson tomorrow. That lesson will not be on your quiz, but we can't just waste time. Or would you rather have the quiz tomorrow?
No.
That's what I thought. We'll wait till do it Thursday, okay? All right, so here we go. What we're going to do from here is your homework. A couple of you have tests that you need to go ahead and start. A few of you have a test that you need to finish before we go to lunch, okay? Got it good? Was it hard today?
No.
I told you it wasn't. I told you it was easy. Yes, quickly. What, baby? Okay.